Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Longest strictly increasing or strictly decreasing subarray. Leetcode 3105. In this problem we are given an array of integers nums and we should return the longest subarray of nums which is either strictly increasing or strictly decreasing. Let's try to understand these terms with this example. So by subarrays what we mean is selecting the contiguous part of the array like 1 or 1 4 or 4 3 and so on. But skipping the elements is not allowed. So for example, we cannot select the elements like 1 comma 3 because we are skipping the element 4 here. And when we say strictly increasing, this means that every element in the subarray is less than the next one. For example, in this array, this subarray is strictly increasing, but this subarray is not because here after going up, we go down. Or if we had the elements like 1, 4, 4, this is also not strictly increasing because now the two 4s are equal. So the elements went up and then they became flat. So because of this subarray is not strictly increasing. And similarly, when we say strictly decreasing, this implies that every element in the subarray is greater than the next one. For example, consider the subarrays 4, 3 or 3, 2. Here the elements are strictly decreasing, but consider the subarray 3, 3. Here they are not because the two 3s are equal. And the subarray of size 1, that is a subarray with a single item, can be considered as both strictly increasing and strictly decreasing. So we can have strictly increasing subarrays of size 1 as 1, 4, 3, 3, 2, and subarray 1, 4 is strictly increasing subarray of size 2. Similarly, for strictly decreasing subarrays, we can have the elements 1, 4, 3, 3, 2 as subarrays of size 1, and the subarrays 4, 3 and 3, 2 are strictly decreasing subarrays of size 2. So the maximum length of the strictly increasing subarray or the strictly decreasing subarray was equal to 2. So we will return 2 as our answer. Now in terms of solution, one of the naive approach can be that we generate every possible subarray of given array nums. For example, for this array we can generate subarrays as 1, 1, 4, 1, 4, 3 and so on. And then for each subarray, we need to check if it is strictly increasing or decreasing. For example, subarray 1 is strictly increasing or decreasing since it's just one element. 1, 4 is strictly increasing, 4, 3 is strictly decreasing, and so on. And the length of the longest subarray will be our answer. And in this example, we have those as 1, 4 or 4, 3 or 3, 2, each of length 2. So we will return 2 as our answer. And in terms of time complexity, generating all subarrays will take O of n square time. And then for each subarray, we check if it is strictly increasing or decreasing. That takes O of n time. So because of this, the overall time complexity becomes O of n cube. And now the question is, can we do better? And the answer is yes. Because we don't need to generate all the subarrays, as in this problem at any point we want to track the strictly increasing subarray or strictly decreasing subarray, which can't exist simultaneously at the same point. For example, consider the subarray 1, 4. This is strictly increasing, but as soon as we encounter element 3, this increasing subarray resets and now we have a decreasing subarray. And from this point, the increasing subarray resets to size 1, that is with one element 3, but decreasing subarray has size 2 now. So we can track these subarrays independently by using two separate variables, increment and decrement, both initially set to 1. These variables help us track if the subarray is increasing or decreasing. And why do we set the initial value of these counters to 1? Because the constraint mentions that the nums array has a minimum size of 1. Hence, the smallest increasing or decreasing subarray we can form are one element subarrays. And thus, the minimum size or the initial size is equal to 1. And then when we traverse through the array and check the current element with the previous element, we have three possible cases. First, the elements are in the increasing order. In that case, we increment the increment counter by 1 since the strictly increasing subarray size is increasing, and we reset the decrement counter to minimum value 1. Or the second case is the elements are in the decreasing order. In that case, we will increment the decrement counter and reset the increment counter. And finally, the last case is when both the elements are equal. In that case, since neither of them are increasing nor decreasing, we will reset both the counters. And at any point, the maximum value among the increment and decrement counters will be our answer. Now let's see this in action. We set the increment counter and decrement counter to 1, and also let's set answer also equal to 1 because it will be maximum of either of them. And then we start from index equal to 1. Why? Because we want to compare each element with the previous element. So to avoid index out of bounds, we start with index equal to 1. So first we compare numbers 4 and 1, and they are in the increasing order. So our increment counter becomes 2 and decrement counter stays 1. And our answer also becomes 2 because we have to track maximum among these increment and decrement counters, right? Then we see element 3, which is less than 4. So that means our increment counter should be reset to 1 and decrement counter should increase to 2. And our answer remains 2 because that is the maximum we have seen so far. Then we see 3 again, which is equal to the previous 3. And now the subarray is neither increasing nor decreasing. So we will reset both increment and decrement counters to 1. And our answer will remain 2. And then we see element 2, which is less than the previous element. And again, the subarray starts decreasing. So we will increment the decrement counter to 2. And our increment counter stays 1. And our answer also says 2. And now we are done with all the elements. And throughout the iteration, the length of the longest strictly increasing or decreasing subarray was 2, which we will return as our answer. And now in terms of time complexity, it will be O of n, where n is the length of the nums array because we traverse each element in the array only once. And in terms of space complexity, it will be O of 1 because we are using few variables here and there. Now let's jump into the code part. First, let's initialize the increment counter, the decrement counter, and answer to 1. These variables will track lengths of current increasing and decreasing subarrays, and maximum among them will be our answer. Now, let's loop through the array starting from index 1. If the current element is greater than the previous element, then we will increment the increment counter and reset the decrement counter. Otherwise, if the current element is less than previous element, then we will increment the decrement counter and reset the increment counter. And finally, if both the elements were equal, then we will reset both the increment and decrement counters. And in the end, the maximum increment or decrement counter we have found so far will be our answer, which we will return once we are done with all the elements. Now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.